Welcome all. So, in the process of time value of money learning, this concept I started in the previous classes, and we are still continuing with the same process of the time value of money, because it is a very important concept. And I discussed in the previous class also that if you are a student of finance or the financial management, you must be well versed with the concept of the time value of money, because at every walk of life or at every decision which is a financial decision, we will have to use this concept of the time value of money. So, we are discussing this, we are learning it, and I want to spend quite some sufficient amount of time on the different concepts and different aspects of this concept of the time value of money, so that we are clear that in later on when we discuss the other concepts and techniques of the financial management or different another say subcomponents of this course or this particular area of learning, then we are very clear about that what we are talking when we are talking about the cash flows, maybe the future cash flows, or the say the present value of the future cash flows or anything. So, means every time we will have to talk in terms of the say discounted value of the future cash flows or the in terms of the time value of money. So, I think we should be very clear about the different concepts of this subcomponent, that is the time value of money. I talked to you that when you evaluate the new investment proposals or the new projects, there it is very important, because cash flows will come sometime in the future and the investment we are going to make it today. So, something coming in the future and something going out of our hands today, both cannot be compared. So, we have to make both the figures comparable, and for making both the figures comparable, we will have to means bring them to the present value, right. So, every time this concept of the time value of money is important, and I am discussing it at detail. I want to spend sufficient time on it. So, in the previous class we discussed just started talking about it, that how the time value of money is important, why it is important, and that we discussed here something that in terms of the present consumption as compared to the future consumption or the productivity of the capital or the inflation factor, because inflation is a one important factor that reduces the say value of the money over a period of time, because in a growing economy, in a developing economy, inflation is a one important factor which keeps on going up. So, when there is a more say availability of the money in the market, people start demanding for more goods and services, and sometimes when the stock of the goods and services is not growing because we are a developing economy, so that leads to the inflation, right. So, because of the inflation or the inflationary trends in the market, the value of the money goes down, it changes also. And you otherwise also in a common man's language, we can also understand that what we can buy for a say sum of 100 rupees today, probably we cannot buy the same amount of the goods and services 1 year hence from now. So, it means it is important that because of inflation, because of some other factors, the value of the money goes down, and we will have to evaluate that how much reduction is there in the value of the money, so that when the future cash flows you are comparing with the present investment, we have to convert that into the present value, right. So, just beginning discussion we had about all this, and we have seen that where this time value of money is important. We have seen that right from the valuing of a single stock, single share, or the return available from the investment in one stock of a company, valuing the whole company or the company as a whole, there lies in between the whole spectrum of the time value of the money lies. So, you can understand the importance of the time value of money. Here is the timeline, right. When you talk about something, here it is a timeline, and understanding this timeline is very important, right. If you look at this timeline, we are given into two parts, part A and part B, right. In the part A, if you look at it, the value is same, and the percentage, that the rate of interest or the discount factor is also same, right. But there are some points where these values are put at different points in the two structures. In the structure A, now we are talking about that we have the how many periods? We have the 6 periods. 0 means present year, present period, current period. 1 is the next 1 year, second 1 year, third 1 year, and then the fourth next year, and the fifth next year, right. So, it means we have this is a 0 period is the current period, maybe 2019, and then 2020, 21, 22, 23, 24, like this is the future number of years are given here in this timeline. rate of interest, cost of capital or discount factor, whatever you call it as, is the 12%, and this cash flow is 10,000 rupees. Now, this cash flow is shown at 10,000 is at the say end of the, or you can call it as, here we have shown it here it as the at the beginning of the or at the end of the say year 1. So, when you talk about here at the end of the year 1, it means these cash flows are occurring to the firm, that this investment has gone in the current period, whatever the investment we are making, we have made that investment in the current period, and then against that investment, now from that project or from that total investment, cash inflows are available. So, first inflow is available of 10,000 rupees, that is at the end of the first year, that is at the end of the first year. Second cash flow is available at the end of the second year, then is the end of the third year, that at the end of the fourth year, and that at the end of the fifth year the cash flow is available, right. Now, here this timeline shows that some cash flows, cash inflows are available at the end of the year. So, we have the two important points to be borne in mind here, that the point of cash flow and the period of the cash flow, right. So, if you are talking about the point of the cash flow, so these are the 2 points, point 0 and this point, right. This is the beginning point, this is the end point for example, and this is the one period, right. This period is from 0 to 1 year, this period is 0 to 1 year. So, this at the end of the first year, how much cash flow inflow is coming back to the firm which he has made the investment in the 0 period. Then the second cash flow is coming at the end of the second year, third cash flow is coming same 10,000 at the end of the third year, at the end of the fourth year and fifth year, so on and so forth. So, these are the cash flows are coming when it is given at a point, that is from 0 to 1, they are the 2 points. This period is the connecting period from 0 to 1, from the current to the next 1 year, a period of 12 months, and that period of 12 months ends at the end of the first year. So, currently in the 0 period, at the current time you made investment, we use that investment for the 1 full year in that project, and at the end of the year, at the end of the first year, we got the inflow of the 10,000 rupees. Then second, third, fourth and fifth, right. So, these inflows are coming at the end of the year, and if you look at the second structure, here you talk it about, here we also have again the points, and these points are 0 to 1, 0 is the one point, 1 is the another point, but the cash flow is shifting from the right hand side to the left hand side. So, here when we are showing that the cash flow is coming to us, so it is not coming at the say end of the first year, but at the beginning of the first year, right. It is coming at the beginning of the first year. So, when any cash flow is coming at the beginning of the first year, it means that has to be discounted in that way, and when it is coming at the end of the first year, it has to be discounted that way. Now, for example, when you talk about when we are making this investment in this 0 period in the current period, whatever that investment, for example, it is not given here, but whatever the investment we have made here is, for example, that investment is 40,000 rupees. Against that investment of 40,000 rupees in the 0 period, we have got the first inflow at the end of the first year, 10,000 rupees. So, what you have to do is, now this 10,000 rupees are not equal to what is the 10,000 rupees at the 0 period. So, now to make this 10,000 rupees equal to this 10,000 rupees in the current period, you have to discount it against the factor of 12%. Then the second one has to be discounted for 2 years at the rate of 12%, this for the 3 years at the rate of 12%, this for the 4 years at the rate of 10%, and this is for the 5 years at the rate of 10%. So, when you discount these cash inflows by applying the say power as n, that number of years, then you will find it out, the discounted value of this 50,000 rupees, 5 cash streams of the 10,000 rupees each will become something that will be discounted value, and that has to be compared with the initial investment of say 40,000 or 35,000 or 30,000 rupees, and then final decision has to be taken whether this investment should be made or not, right. In the second case, when you talk about the inflows are occurring at the beginning of the year, right. So, again it is connecting 2 points, and the one period is here, that is 0 to 1, this is the second point 1 to 2, this is the third period, fourth period and fifth period. Periods are same, periods are not changing, discount factor is also same, that is also not changing. But what is the difference here, that when we are making the outflow, when you are making the investment in the 0 period, the inflow, first inflow is also coming at the beginning of the first year. It means at the beginning of the first year means the 0 period itself, that inflow is coming. So, it means when that inflow is coming in the beginning of the year means beginning of the first year is the 0 period. In that case, this 10,000 is equal to 10,000, the value of the 10,000 is equal to 10,000. This will be discounted for 1 year, this will be discounted for 2 years, this will be discounted for 3 years, this will be discounted for the 4 years, right, because this cash flow is coming at the beginning of the year. So, this is coming 1 year in advance, this is coming 1 year later. So, here when you will apply it, the first cash flow has to be discounted for 1 year, whereas in this case the first cash flow has not to be discounted at all, because it is coming in the beginning year, which is equivalent to the value of any investment we are making or inflow we are getting in the current period. So, here discounting will differ. The points we have to think about, at what point the inflow is coming back to us and for what period. This is for the period, but this inflow is coming in advance to us. In the second period from 1 to 2, for the second year, the inflow is coming at the beginning of the year. It may be possible that, for example, we have made some investment in some asset. Both the situations are possible, that for example, we have made some investment for some asset and that asset is rented out, right. Here in this case, that asset is rented out and the rent agreement, that asset is leased out. So, the rent agreement says that at the beginning of every year the rent will be paid by the borrower or the person who is using that asset or to whom it has been lent out. It may be a machine, plant, building machinery, anything, that he has to pay the rent in the beginning of the period, not at the end of the period. So, what is happening, we purchased a machine for 1 lakh rupees and or for the 50,000 rupees and we rented it out, right. And so, it means in the 0 period our outflow is how much, 50,000 rupees, right. So, that 50,000 rupees is equal to 50,000 rupees, or that 40,000 rupees is equal to 40,000 rupees, whatever the price of the machine. And when it is lent out to somebody for the use, then it was the agreement, condition in the agreement, that while you will receive the machine for using, before you start using, you will pay back the first year's rental value back to the supplier, right. So, it means in the 0 period the investment is 40 or 50,000 rupees and the 0 period itself, maybe in the beginning of the first year, the first cash inflow is coming and that is of the 10,000 rupees. So, it means the first 10,000 is equal to 10,000, remaining that again 4 streams of the 10,000 rupees each, they have to be discounted for different periods. So, the second one has to be discounted for 1 year, this has to be discounted for 2 years, this has to be discounted for 3 years and this has to be discounted for the 4 years. Whereas, in this case it is again connecting 2 points, point 0 to point 1, and the period becomes the first year. 0 to 1 is the first year, the total 1 year's period is the first year, but the cash flow is occurring at the end of the year. So, when it is occurring at the end of the year, it means all these 5 cash flows have to be discounted against this discount factor of the 12%. Whereas, in this case we have to discount only 4 cash flows for a period of 4 years maximum, and the first one has not to be discounted because it is occurring in the current period. So, timeline is very important. You have to be very careful when the cash inflow is occurring from any investment, from any project. When the cash inflow is occurring, if it is occurring in the beginning of the period, then the period of the discounting will be different, and if it is occurring at the end of the year, then the period of discounting, total period of discounting will be different. So, we have to be very careful. Number 1 is the point of cash flow and the period of the cash flow. If you talk about the point, then here it is occurring at the 0 point, here it is occurring at the point number 1. At this point, this is occurring at this point, this is occurring at this point. This need to be discounted because period of the 1 year is already over. So, whatever the cash flow is coming to us after 1 year, that cannot be equal to the cash flow coming in the current period, that too in the 0 period, right. So, this timeline is very important while understanding the concept of the time value of money. Now, we will discuss some important things. I told you in the previous class also that in the time value of money, we will try to learn about the concepts of future value of the present say cash flows, future value of the present investment and the present value of the future cash flows. These are the two important things we have to make use of and we have to learn about it. Normally we confront with the two kind of decisions, that we have certain amount, the sum in our hands, we want to invest that in the market, and we want to find out that after certain period of time, if I invest this 10,000 rupees, after 5 years periods of time, what will this 10,000 rupees will become for a given rate of interest. Or for example, another way around, if we make a investment of some amount in the beginning, say 50,000 rupees we invest in the market, and somebody says that after 5 years I will return you back 80,000 rupees. So, you are now, this is a major question which comes in our mind is that if I am giving 50,000 rupees in the beginning of a period, and then after 5 years that user of those funds is returning back me 80,000 rupees, then how much interest I have earned, that is the annual rate of interest is going to be how much. So, this is regarding the say the future value of the present investments or the present cash flows, and second question comes up is the present value of the future cash flows. Whatever the investments we make in the market in terms of the projects or maybe any kind of investments, where the cash outflow occurs in the current period in the 0 period, but the cash inflow comes over a say period of subsequent number of years. So, then we have to compare the two. I have been time and again I have been say emphasizing upon that the time value of money is important for the investment proposals also. So, here for example, we learn about, first we will learn about the future value of the single amount, then we will learn about the future value of an annuity. Similarly, we will learn about the present value of the future cash flows, maybe if they are even same cash flows are occurring. For example, in this case when you talk about we are getting the same cash inflow of 10,000 rupees at the beginning or at the end of every year, right. So, you have the two situations, either the cash flow is remaining the same or that cash flow is uneven. Normally the cash flow becomes uneven because when we receive that back over the number of years, that remains uneven, and uneven cash flow has also to be discounted. So, we have to solve this problem also. So, future value and the present value, these are the two important things we have to learn in this entire process of the time value of money. So, now I am just going to talk to you about is the future value of a single amount. If you talk about the future value of a single amount, so it means for example, we are saying here that there are the 3 years given to us, the period of 3 years is given to us, and what is happening here, that we have a principal amount of that 1,000 rupees which is invested in the beginning of the year, right, and the rate of interest is 10%, right, interest for the year is 10%. So, what will be the amount of the principal amount, that the principal amount will become 1,100 at the end of the first year. Second year, now we are reinvesting back this 1,100 rupees, and again the rate of interest is 10%. So, this amount will become 1,210. Third year, now this amount is reinvested back, and we have the again same rate of interest, and that rate of interest is say again 10%, this is added into it. So, at the end of the year, so your total amount comes up is 1,331, right, this amount is 1,331 is the total amount. So, you can call it as 1,000 rupees invested in the beginning of the first year at the rate of 10% has become 1,331 rupees at the end of the third year. But here you have to be very careful that which rate of interest was it. It is only that 10% is given to us here, 10% rate of interest is given to us. Rate of interest are of the two types, one is the simple interest, second is the compound interest. One is the simple interest, second is the compound interest, and we will learn about the magic of compounding, which is a very interesting magic, and it grows, it increases your money in the geometrical progression, and under the compounding say process, what we do is we make investment of some basic amount and we earn interest on that after certain period of time, but we do not take the interest back from that investment, and that investor or the fund manager reinvests the interest earned on the first period again back for the second period. So, second period the base of the investment increases, as in this case we have seen 1,000 invested in the first year, we earned interest of 100 rupees. So, second year this amount becomes 1,100. There could have been the another option available with you, that the investor could have opted for that interest part I will be withdrawing every year, and only principal amount has to be invested for the second year and the third year, or maybe for the any number of the subsequent years. So, in that case that will become the simple interest. That interest, whatever the interest you are getting is, that will become the simple interest, because you are getting that interest stream of, say for example, in this case you got the interest of 100 rupees that you withdraw, or the fund manager has paid you the interest. So, again how much is left with us? 1000 rupees, and 1000 rupees we are investing back for one more years, again 100 rupees is available. So, that is a simple rate of interest. So, here when you are calculating in this way, when the interest earning is also reinvested back along with the principal amount, this process is called as the process of compounding, and by using the compound rate of interest, you can calculate the future value of any present amount. And when you apply this concept, this is the way how this process works, and the future value of a single amount applying the compound rate of interest of, say here in this case 10%, becomes this 1000 rupees becomes 1331. If you want to see how it has happened, because it is only a very simple figure of the 1000 rupees and the rate of interest is 10% and only for a period of 3 years, but you talk about the investment of the millions and billions of rupees which has to be made for the next 20 years, and there we have to say calculate the interest rate, or we have to find out the compound amount or the final amount it is becoming after 10 years or 15 years or 20 years. There this simple calculation will not work. You cannot do it manually, you cannot do it with any calculator. You have to use the efficient IT systems, softwares, where this all your formulas and everything is fed, and automatically when we give the values, you put the value of any investment amount you want to make invest, rate of interest is this and period is this, immediately the result comes out from your computer that this amount is going to be this after the end of this desired amount of the period. That may be a period of 10 years, 12 years or 15 or 20 years. So, what we have to do is, there is a formula, clear cut model given to us is future value model is given to us, and what is the future value model? Present value in this case is 1000, present value into 1 plus r power n. 1 plus r is basically what is this? Rate of interest, and what is n? Number of years. So, if you multiply the present value with the 1 plus r, maybe the interest factor, and for the number of years with the power of say number of years, then you can easily find out any amount will become how much for a given rate of interest. But the important point here is, you should be knowing all these three things. First, you should be knowing the present value or the investment you want to make, then you should be knowing the the rate of interest which somebody is offering, where the investment is going to be made, and third important thing is the number of years for the period for which the investment is going to be made. If these three things are known to us, by applying this model we can calculate the fourth thing, and that fourth thing is that how much that present value investment that we are going to make in particular revenue will become how much, right, will become how much. So, this is the process of compounding, and this is used for calculating the future value of any amount, provided that is the single amount. Now, as I told you that for the small these calculations you can directly do it with the help of calculator or manually, or maybe in any way you can do it, but for the bigger investments you have to use the very sophisticated IT softwares. So, for the facilitation of calculating these future values of any amount, we are already given this multiplication factors, right. These factors are already calculated in any book, good book on the financial management. The one which I am following, that is the Financial Management by Prasanna Chandra. At the end of the book the table is given, and from that table all these values can be found out, right. So, for example, we are given here the different rates of interest horizontally 6%, 8%, 10%, 12%, 14%, and on this vertical side we are given the number of years. 2 years, if the period of investment is 2 years and rate of interest is 6%, whatever your basic amount is you want to invest, you multiply this by this factor 1.124, you can easily find out the value coming out will be the value which will be becoming after the period of 1 year, after the period of 2 years, right. So, with the help of this table, this is called as the future value interest factor tables. So, with the help of this you can easily find out, and these future value interest factors are worked out for the different durations by assuming the certain rates of the interest which are prevailing in the market. So, these tables which are pre-calculated available almost at the end of every book of the good book of the financial management, you can make use of it. So, simply you multiply any investment 1000, 2000, 20,000, 1 lakh, 2 lakhs by say this future value interest factor, and you will find out the amount which is becoming something like this. Now, for example, if you look at these factors, there is one important point to be borne in mind. These factors are 1 point something, they are more than 1, right. These factors are more than 1. So, it means you can easily find out that if you multiply any amount by this factor or this factor or this factor or this factor or this factor, that amount will become more than what it is currently with us. And what is that more than? That is just 1 plus r power n, 1 plus r power n. So, your amount will become, that is the present value and plus interest on that and interest for that number of years. So, that amount will become. So, this table is automatically showing always 1 point something which is more than 1. So, your investment will always grow from the present value, always it will be more than that. So, this table is you are finding it out here is that all the factors are 1 point something which is more than 1, whereas if you look at the table of the present value interest factor PVIF table, there the factor will be less than 1, it will be 0 point something, right, because we know that the present value of the future cash flows will be lesser. When you convert that into the present value, the future cash flows value, when it is converted into the present value, it will be lesser than what we are going to receive in future. Practically it is going to be lesser in the today's terms. So, that factor will automatically be less than 1, but this factor is more than 1 because you are calculating the future value of the present investment. So, that will grow because of the interest plus the number of years for which we are making the investment in the market. Then now we talk about the certain say related concepts with the future value of a single amount and other things. Now, for example, we are given a small problem here. Suppose you suppose you deposit rupees 1000 today in a bank which pays 10% interest compounded annually. Suppose you deposit rupees 1000 today in a bank which pays 10% interest compounded annually. How much will the deposit grow to after 8 years and 12 years? Now, it is a very simple thing, that because the 10% interest which is compounded annually, annual compounding. This is the process of the annual compounding. So, if you want to calculate it here, you can easily find out that how you can calculate this. The amount given to us is, how much is the amount given to us? That is the amount is 1000 rupees which we want to deposit in a bank. Rate of interest bank is giving us 10%, compounding is annually, and the period is, we are given the 2 periods, one period is 8 years and the second period is 12 years. So, now how you have to put it, how you have to make it. So, this is the investment of, how much is the investment? This investment of 1000 rupees we are going to make, and what is the this increase, this is the rate of interest, and power is 8 years, we are going to make the power is 8 years. So, if you do like this, you can find out some value. And in the second case, when you are going to talk about is, it may be a period of 12 years. So, it is going to be how much? 1.10, and only the period is going to change. In the first case the period is 8 years power n. So, in the first case the period is 8 years, in the second case the period is 12 years. So, if you give the power n, so what will be give this? It is 1000. For example, can we go for this, we can find out the factor, if it is for the rate of 10% and for the period of 8 years. Now, let us see if it is given, this value is given to us or not. So, this rate of interest is 10%, right, and period is 8 years. So, this is given to us, this is a period of 8 years, this is the rate of interest is 10%, this is also given to us 10, and a period of 12 years is also given to us, this is this. So, what we will do, our job is very simple now, you will have to multiply this investment with this factor. So, what we are going to do here is, we are going to do multiply by that factor, and what is the factor we have seen from the table is, the factor is 2.144, this is the factor. If you multiply this, this investment becomes how much? Rupees 2144. This investment becomes 2144. In the second case, what is the factor? If you look at the factor here and if you go back and if you try to find out the factor, factor is 3.138, right. This is the 3.138, and if you say multiply this 1000 with this factor 3.138. So, what will be this? This investment will become 3138. This investment will become 3138. So, this job is very easy because these factors are easily available with us. Otherwise, what was the case? You had to apply that model. One, that present value 1000 into 1 plus r power n. So, you have to write there 1 plus the r is the rate of interest is 10% and power is 8. Same is the case with the second. So, we do not need to do any all these calculations now afresh. This information is available from the future value interest factor table. From there you pick it up. Only you should have to know is the rate of interest and the number of years. If these two things are given to us, you can simply apply the present investment or the present value of the investment with that factor, future value interest factor, and you will find out the amount. In this case, if 1000 rupees invested today for a period of 8 years and the rate of interest is 10% and compounding is done annually, then this amount will become 2144. In the second case, if 1000 rupees is invested at the rate of 10% for the period of 12 years and the compounding of the interest is done annually, once in a year compounding takes place, then this amount of 1000 rupees at the end of the 12 years will become 3138. Very simple, right. So, now you can understand here the compound interest, the magic of compounding. For example, if you calculate it as a simple interest for a period of 8 years and a simple interest for a period of 12 years, this will not become this much. This will not become 1000, 1000 will not become 2144 at the end of the 8 years. Similarly, the 1000 will not become 3138 at the end of the 12 years. It will not become like this, right. So, just because of the magic of compounding, power of compounding, this figure has grown up to this. So, this figure of 1000 has become 2144, right. Now, these days you must be hearing about the period of compounding has come down. If you go to banks or financial institutions, then the compounding is now the period of compounding is being reduced, right. It may be half yearly compounding, it may be quarterly compounding, and it may be monthly compounding, and these days if you talk about in the banks, there is a daily compounding. There is the daily compounding that on both the borrowings also, on the lendings by the banks also, there is a daily compounding. If you borrow any money from the bank, whatever the loan you are borrowing from the bank, the interest bank is charging, that is being compounded on the daily basis, right. They are calculating the interest on the daily basis, and on the today's interest means tomorrow what will be the amount outstanding in your loan account, the borrowing, the total. For example, you borrowed 10,000 rupees for a period of 1 year and you have not paid anything. So, the day you have the amount has been transferred to your account or you have withdrawn that amount, from that day onwards you have not returned any amount, any installment back to the bank. So, bank will start calculating the interest, and the interest is for a at the rate of 10% for a period of 1 year we have borrowed 10,000 rupees. So, at the end of the first day evening, this amount will become 10,000 plus the interest at 10,000 at the rate of 10% for that particular day, 1 day. So, next day, that second day, in the beginning of the second day morning, that loan amount will not be only 10,000, it will be little more than 10,000, because interest for 1 day at the rate of 10% has been added. So, this is called as the concept of the daily compounding. Same is the case, it is being done on the deposits also. When we give the deposits in the banks, so there they are also doing calculating now the interest on the daily balances. So, daily compounding is being done. So, now you can understand how complex it is. Even if doing the annual compounding once in a year, when we had to do the compounding, we have to apply that model of present value into 1 plus r power n. So, if you are doing, if you are lowering down the periods, it means in 1 year there are the 365 days and 365 times you have to compound the amount. So, this is not manually possible, we have to do it with the very efficient IT systems. When there was no IT system available in the banking system or in our financial institutions, then compounding was being done very say simply once in a year, annual compounding was there. Then when we started introducing the IT systems, compounding came down to say 6 monthly compounding, then it came down to quarterly, then it came down to monthly, then it came down to means these days now it is a daily compounding, both on the borrowing and both on the deposits. In the banking system, the compounding is done on the daily basis. So, your amount is also growing at a very faster rate, means the loan amount is also growing at a very faster rate. So, whatever you are borrowing today and whatever you return totally at the end of the period back to the bank, there is a big difference. Bank is charging a high amount, and same is the case with the deposits. What you are depositing today and what you are withdrawing. For example, if it is a fixed deposit, what you are withdrawing at the end of that say fixed term, that there is a difference in the two amounts. But there is another important point of caution here, or maybe not caution I would say, but of interest, that though the compounding has become daily, but the rate of interest has come down. The rate of interest has come down. If you talk about the deposits, there was a time in the say 10-15 years back, the banks were paying us 10 to 12 to sometime 15% rate of interest. These days now the rate of interest has come down to 6% of the fixed deposit of 3 years and more, and on the saving deposit it is somewhere 3.5%. Same is the case on the loans also, the interest rate has come down. So, in both the cases, means if the compounding has become very robust, so the interest rate has come down. So, we are being compensated because of the one negative factor, we are being compensated by the one positive factor as far as the loan is concerned. But in case of the deposits, yes, we have been benefited by the daily compounding, but the rate of interest has come so down, and it is further taxed also, the interest we are earning. So, that say investment in the banks has not become has not remained as very lucrative or very rewarding. But this is the concept of compounding which I thought of discussing with you. Now, we talk about the say simple rate of interest. If we talk about the simple rate of interest, so in the simple rate of interest what we are doing? We are calculating here again the future value we are calculating, but the model is different. The model is different. There the model was 1 plus r power n. Here the model is present value into 1 plus number of years into interest rate, that is 1 plus number of years into interest rate. So, for example, this the model is different. There was 1 plus r, the simple rate of interest, but here we are talking about 1 plus number of years into interest rate. So, and no, there is no power n because there is no compounding at all. So, this is only for the given number of years simple rate of interest. So, this difference in the model will tell you that there is a difference in the two kinds of the rates of interest. Now, here for example, we are given this information, an investment of rupees 1000 if invested, an investment of rupees 1000 if invested at 12% simple rate will in 5 years time will become how much? For example, an investment of rupees 1000 if invested at 12% simple interest rate will in 5 years time become how much? 1000 rupees invested at a simple rate of interest of 12% in 5 years period of time, how much will it become? So, what is the formula here? PB, present value, here present value plus number of years into interest rate, right. So, how we can calculate it? That is the present value. We have to calculate now the future value. So, here it is the present value into what we have to do here is that is 1 plus number of years. The model says 1 plus number of years into interest rate, right. So, I think this is the model. We have taken 1 plus number of years into interest rate, 1 plus number of years into interest rate, and what is the amount given? 1000, 12% and 5 years, right. So, here we have to take is the present value is how much? 1000 and 1 plus number of years is how much? 5 into what is the interest rate? Rate of interest is 12%. So, you can call it as 0.12. If you multiply, if you solve this, how much it becomes? 1000 into 1.6, this becomes 0.6. So, if you multiply 5 0.12 by 5, this becomes 0.6. So, this becomes 1.6, and if you multiply 1000 by 1.6, this amount becomes as 1600 rupees. So, this amount will become 1600 rupees. Here now you can find out the difference. When you are investing 1000 rupees at the rate of 10%, here it is 12%. When you are investing 1000 rupees at the rate of 12%, at a simple rate of interest, at the end of the 5 years, this amount is simply becoming 1600 rupees. But when you are investing 1000 rupees just for 3 more years, but at a lesser rate of interest of the 10%, not of the 12%, at the rate of 10%, this amount is becoming more than double, though the number of years is 3 more, but the rate of interest is less by 2%. So, you can understand here the amount is just 1600, here the amount is becoming more than double, that is 2144, and if you are increasing the number of years at the same rate of interest of 10%, then this amount is becoming more than 3 times. So, this is called as this is on the one figure on the one side, this is another figure, this is another figure. So, you can understand the difference in these 3 figures. This is at the simple rate of interest, these 2 are at the compound rate of interest. So, this all is explaining very nicely, very clearly the magic of compounding, the power of compounding. So, you can understand what is the difference between the simple rate of interest and the compound rate of interest. So, this is something I wanted to talk to you about, the future value of a single amount and how we can calculate the future value of a single amount and how we can work out that final value, future value, whether the rate of interest means we are applying compounding or we are applying the say a simple rate of interest, what will be the say the future value of the present amount. Further more discussions with regard to this time value of money and the future and the present value of money I will have in the say in the coming classes. So, for this class I will stop here and remaining concepts we will discuss in the next class. Thank you very much.